How are you? I am Teacher Marlene. Before we begin exploring the lesson, I need you to, number 1, read and follow all the instructions before answering each assessment related in this video. Number 2, the yellow arrow points to clickable transparent icons like pen, laser pointer, highlighter, next and previous arrows, zoom in and out, and the menu plus icon. And number 3, have fun while learning and be patient watching my video lesson for today. These are what I expected you to do at the end of each learning episode. 1. Identify the general pattern of a scientific investigation and enhance your spelling and vocabulary words. Number 2. Perform various activities to demonstrate an understanding of the concepts. Number 3. Realize the use of a scientific approach in dealing with a problem and in any observable phenomenon. Allow me to give you a pre-test. This is a multiple choice type of test. Choose the letter of the correct answer. After reading a question, on click, each letter reveals a statement or your choices. You can click the letter of your choice. The letter color changes from black to green once you hit the right answer. Let us have number 1. What describes a scientific method? Is it letter A, a way scientists make problems and ask questions? B, a way scientists answer questions and solve problems? Or letter C, a way scientist does not have an answer to problems? Letter D, a way scientist hides the solution to a problem? You are correct. The answer is letter B. A way scientists answer questions and solve problems. Number 2. Which characteristic describes a good experiment? Attainable, A. B. Explainable, C. Questionable, and D. Testable. Okay, the right answer is letter D. Testable. Number 3, what is the correct order of the steps of the scientific method? A. Observations, questions, hypotheses, experiments, interpreting results, and making conclusions. B. Observations, questions, predictions, experiment, interpreting results, and making conclusions. C. Questions, hypotheses, experiment, interpreting results, and making conclusions. And D. Questions, hypotheses, predictions, experiment, and interpreting results, and making conclusions. Think of your answer. Correct. The answer is letter A. Observations, questions, hypotheses, experiment, interpreting results, and making conclusion. Number 4. The Pasig General Hospital Frontlines wears a complete personal protective equipment in white overalls, a green protective mask, a plastic-made face shield, and a blue hand surgical mask. What is this statement referring to? A. Generalization, B. Hypothesis, C. Inference, and D. Observation. I know you know the answer. Correct, it's letter D. Observation. Number 5, which describes the end of a research process. A. The hypothesis will always be approved. B. The hypothesis may be rejected. C. The hypothesis may be approved or rejected. D. The hypothesis will have not affect the investigation. Very good. The answer is letter C. The hypothesis may be approved or rejected. Now let me ask you this. How often do you go to church with your family or friends? Are you familiar with this old church in Pasig City? On your way to the cathedral together with a friend, you notice that your wallet is missing. What would be your initial reaction? What must you do to find your missing wallet? Alright, let us continue so you can find your wallet using this scientific technique, the scientific way of investigation. A scientific investigation is a plan for asking questions and testing possible answers in order to advance scientific knowledge. It follows a certain pattern to guide you in case your teacher will ask you to make a classroom experiment or an investigatory project. It uncovers so many questions about the things around us. It has two components such as science process skills and manipulative skills. It includes the application of scientific knowledge and problem-solving skills. To highlight the basic plan and its purpose, this is often presented in a simple recipe called the scientific method. The scientific method is a way to ask and answer scientific questions presented in a series of steps. Number 1, make an observation. Number 2, identifying the problem. Number 3, form a hypothesis. Number 4, design an experiment to test your hypothesis. Number 5, gather and analyze data and results. And number 6, draw a conclusion. In making an observation, researchers like you make use of their senses to spot problem areas around them. In identifying the problem, you ask questions. Why, how, what, about what you have observed and you want to investigate. In the formation of your hypothesis, it should be based on your gathered information. Make an educated guess about what type of things affect the system you are working with. Identifying variables is necessary before you can make a hypothesis. A hypothesis is an educated guess about the relationships between the independent variable and the dependent variable. Make a list of your answers to the questions you have using the if-then format. This can be a list of statements describing how or why you think the observed things work. These questions must be framed in terms of the variables you have identified. Example, if 50 ml of water are added to my plants each day and they grow, then adding 100 ml of water each day will make them grow even more. In designing an experiment to test your hypothesis, you should make a step-by-step list of what you will do to answer each question. This list is called an experimental procedure. In this stage, materials for the experiment must be readily available, and precautionary measures shall be strictly followed to avoid accidents. Recording of the result is necessary, like data, graph, and description of the observed outcome. There are 3 variables in an experiment. First one, we have the independent variable, or a manipulated factor that intentionally varied by the experimenter. In a data or in any graph, it is placed in the x-axis. The dependent variable is a responding factor that may change as a result of changes made in the independent variable or plotted in the y-axis. Control group serves as the standard comparison in all experiments. It is exposed to the same conditions as the experimental group except for the variable being tested. The next one is when you gather and analyze data and results. You must record what happened. This can be presented in a form or in the form of a table of processed numerical data or graphs. It could also be written or a written statement of what occurred during experiments. It is from calculations using recorded data that tables and graphs are made. Studying tables and graphs, we can see trends that tell us how different variables cause our observations. And the last is drawing a conclusion. Using the trends in your experimental data and your experimental observations, try to answer your original questions. Is your hypothesis correct? Now is the time to pull together what happened and test the experiments you did. You can make recommendations to your conclusion. If your hypothesis is not correct, what could be the answer to your question? You must remember all of this. Then, summarize any difficulties or problems you had experimenting with. Do you need to change the procedure and repeat your experiment? What would you do differently next time? And you may also list other things you learned. Now here are the list of the activities that you will answer after the video. Number 1. Complete the science investigative crossword puzzle. Activity number 2. Arrange the correct pattern of the scientific method by putting a number in a box on top of each word. Activity number 3. Draw lines from the dots to match the words in the left item or A to the situation in the right item or B. Let us summarize. To summarize what you have learned, supply the words that will complete the concept below. Choose the words in the box below. These are generalization, problem, observation, data, hypothesis, experimentation, scientific method, and conclusion. The scientific method is an ongoing process of investigation wherein researchers make the observation around them to spot problem areas. Then they identify the specific problem they want to study. They can start asking how and why certain phenomena happens. They will gather data from all available resources in the library, internet access, consultation, and interview with an expert as well. Researchers make use of hypotheses, which is derived from the preliminary data that have been gathered. This investigative tool is a tentative answer to the problem that still needs to be tested through experimentation. The data gathered from the experiment will undergo analysis and interpretation so that the researcher can draw a conclusion about the problem they are investigating. They can make recommendations for further study and possible improvements to the procedure done during the experiment. Did you understand today's lesson? Color the smiley of your choice that reflects your learning emotion in today's lesson. Another one, what were the main points of today's lesson? Briefly write your answer in the cloud. Previously, you were able to answer the pre-test. Now get ready to answer the post-test. Number 1. Lying in bed, you notice that you get cold every time your brother opens the door. This is most closely associated with which step in the scientific method? A. Drawing a conclusion. B. Developing a test. C. Forming a hypothesis. Or D. Making observations. Correct. The answer is letter D, making observations. Number 2. What is the last step in the scientific method? A. Communication of results. B. Drawing out a conclusion. C. Hypothesis formation. And D. Making observations. You got it right. It's letter B, drawing out a conclusion. Let us have number 3, a series of steps designed to help you solve problems and answer questions. A, experiment. B, hypothesis. C, observation. D, scientific method. Correct. A series of steps designed to help you solve problems and answer questions is letter D, scientific method. Number 4 question. Which of the following hypotheses is written correctly? Is it letter A? If a tennis ball is frozen, it won't bounce as high as one that is not frozen. B. If I freeze a tennis ball, then it will not bounce as high as the one that is not frozen. C. Frozen tennis balls will not bounce as high. D. If I hit a tennis ball, it will bounce high. Very good. The answer is letter B. If I freeze a tennis ball, then it will not bounce as high as the one that is not frozen. Number 5. It is a process skill where you design an investigation, including a procedure to test a hypothesis. A. Communicating. B. Experimenting. C. Formulating a hypothesis. And D. Interpreting a data. Think of your answer. Very good. The answer is letter B, experimenting. Now remember this. The borrowed materials like stories, songs, videos, pictures, brand names, trademarks, and other used in this material for educational purposes are owned by their respective copyright holders. Credit goes to their original owners. The author does not represent nor claim any ownership over them.